Every advanced car mod explained. Vehicle transformations. True advanced modifications begin with fundamentally changing a vehicle's architecture. These aren't upgrades. They're complete reconstructions that require professional engineering expertise. Full-tube chassis construction replaces factory unibody structures with purpose-built space frames. These provide ultimate rigidity, weight optimization, and safety for professional racing applications. Each tube is precisely bent, fitted, and welded to create a structure stronger than any factory chassis. Monocoque chassis fabrication creates one-piece carbon fiber or composite shells. This Formula One and LMP technology requires advanced composite engineering, autoclave curing, and specialized tooling. The entire vehicle structure becomes a single, incredibly strong and lightweight unit. Complete platform conversions transform fundamental vehicle characteristics, converting front-wheel drive to all-wheel drive, or transplanting entire drivetrains between unrelated platforms requires custom engineering of every system. Custom suspension geometry design relocates pickup points and redesigns suspension kinematics using CAD simulation and engineering analysis. This goes beyond adjustable components to completely reimagining how the suspension operates. These modifications require motorsport engineering expertise, specialized fabrication equipment, and often make vehicles unsuitable for street use. The investment typically exceeds $50,000 to $100,000 and requires professional shops with racing experience. Engine swaps. Complete engine swaps represent the ultimate powertrain transformation. These aren't simple bolt-in procedures. They require custom engineering of every system to integrate power plants never designed for the chassis. LS engine swaps into non-GM platforms require custom engine mounts, transmission adapters, wiring harness fabrication, cooling system integration, and exhaust system design. The complexity multiplies when swapping into vehicles with different engine orientations or mounting locations. Two JZ swaps into non-Toyota chassis present even greater challenges due to the engine's size and weight distribution. Custom subframes, suspension modifications, and extensive fabrication work are required for proper integration. Electric vehicle conversions represent the cutting edge of powertrain swaps. Tesla motor installations require high-voltage electrical expertise, battery pack integration, thermal management systems, and custom motor mounts. These conversions often cost $30,000 to $60,000 and require specialized safety equipment. Rotary engine swaps into non-Mazda platforms require understanding of rotary-specific requirements, including oil injection systems, unique cooling needs, and specialized tuning requirements. Modern engine swaps often retain factory electronics through complex integration work. This maintains features like traction control and emissions compliance, while providing the performance benefits of engine swapping. Forced induction. Exotic forced induction systems push beyond conventional turbocharging to configurations that require custom engineering and professional expertise. Compound forced induction combines superchargers for low RPM boost with turbochargers for high RPM power. These eliminate lag while providing massive power potential, but require custom intake manifolds, complex plumbing, and sophisticated engine management. The Lancia Delta S4 rally car pioneered this technology, producing 500-plus horsepower from 1.8 liters. Modern systems require custom intake manifolds, complex intercooler plumbing, and cost $15,000 to $30,000. Staged turbocharging uses multiple turbos in sequence. Small turbos for low RPM response, feeding larger turbos for high RPM power. This requires custom manifolds, complex wastegate control, and precise tuning to manage the transition between stages. The Bugatti Veyron's quad-turbo W16 demonstrates this technology's potential. Liquid nitrogen injection provides extreme charge cooling by injecting liquid nitrogen into the intake stream. This exotic system requires specialized storage, delivery systems, and safety equipment. Due to the extreme temperatures involved, small quantities reduce intake temperatures by 100 to 200 degrees Fahrenheit while adding oxygen content. Power gains of 50 to 100 horsepower are possible, but safety requirements limit applications to dedicated drag racing. Methanol injection provides charge cooling and octane enhancement for extreme boost levels. Methanol's high latent heat of vaporization reduces intake temperatures by 100 degrees Fahrenheit, plus while providing 105 plus octane rating. Systems require corrosion-resistant components and careful tuning to prevent engine damage. Multi-stage nitrous uses progressive nitrous activation for maximum power without wheel spin. Professional systems use up to 4 stages with electronic timing control. These systems can add 500 plus horsepower, but require extensive engine strengthening and precise tuning. Custom cooling systems for extreme applications include liquid nitrogen cooling, phase change cooling, and exotic heat exchangers designed for specific thermal loads. Variable geometry turbo retrofits adapt racing technology to street applications. These systems adjust internal turbo geometry based on operating conditions, providing excellent response across the entire RPM range. Anti-lag systems with flame control create continuous combustion in the exhaust manifold to maintain turbo spool. These require standalone engine management and significantly increase exhaust system stress. Active systems. Active systems represent the pinnacle of automotive technology, using computer control to continuously optimize vehicle performance. Pneumatic valve systems eliminate traditional valve springs, using air pressure to control valve operation. This Formula One technology allows precise valve timing control and eliminates valve float at extreme RPM. Active suspension systems use computer-controlled actuators to adjust suspension geometry, ride height, and damping characteristics in real time. These systems can optimize handling for specific track sections or driving conditions automatically. The McLaren F1 pioneered this technology for road cars, providing Formula One level handling with luxury comfort. Modern magnetorheological systems change damping through electromagnetic fields, but cost $50,000 to $100,000. Magnetorheological dampers change their characteristics through electromagnetic fields. These systems provide infinitely variable damping control based on road conditions and driving inputs. Active aerodynamic systems adjust wing angles, ride height, and aerodynamic components based on speed, steering input, and track conditions. These require sophisticated control systems and precise actuators. The McLaren P1's rear wing adjusts automatically for maximum downforce or minimum drag. Professional race systems optimize aerodynamic balance for specific track sections using GPS and telemetry data. Hydraulic ride height systems provide real-time adjustment for aerodynamic optimization, ground clearance, and handling characteristics. These are common in prototype racing and high-end supercars. Racing technology. Professional racing technology brings Formula One and prototype racing capabilities to advanced builds. Professional telemetry systems provide real-time data transmission between vehicle and pit crew. These systems monitor hundreds of parameters, including engine performance, suspension loads, tire temperatures, and driver inputs. Custom traction control systems use wheel speed sensors, accelerometers, and engine management to prevent wheel spin. These systems are programmed for specific applications and track conditions. Launch control provides consistent drag racing starts by managing clutch slip and engine RPM. Two-step rev limiters maintain RPM while building boost pressure. Professional systems cost $10,000 to $25,000 and can reduce 60-foot times by several tenths through optimal launches. Racing fuel cells provide safety through foam-filled construction and breakaway fittings. These systems require custom mounting, fuel pumps, and plumbing while meeting FIA safety standards. Professional installations cost $3,000 to $8,000 and provide crash protection impossible with factory tanks. GPS-based data acquisition systems provide track mapping, sector timing, and performance analysis. These systems help optimize setup and driving technique through detailed data analysis. CAN bus integration allows communication between multiple electronic systems. This enables coordinated control of engine management, suspension, aerodynamics, and safety systems. Motorsport wiring harnesses use military-spec connectors and shielded cables for reliability under extreme conditions. Professional harnesses eliminate unnecessary circuits while providing expansion capability for additional systems. Custom harnesses cost $3,000 to $10,000 but provide race-level reliability. Fabrication. Extreme custom fabrication creates one-off solutions that push beyond commercially available components. Custom suspension pickup point relocation requires structural analysis, load path understanding, and precise fabrication. This allows optimization of suspension geometry beyond any adjustable component. Carbon fiber monocoque construction creates incredibly strong and lightweight structures. This requires specialized tooling, autoclave curing, and advanced composite engineering expertise. Gearbox conversions. Quick change differential systems allow gear ratio changes in minutes rather than hours. These racing-derived systems use specialized carriers and mounting systems for rapid setup changes. Sequential gearboxes use dog ring engagement for lightning-fast shifts without clutch operation. These racing transmissions require custom bell housings, shift actuators, and engine management integration. Professional conversions cost $15,000 to $30,000 but provide sub-100 millisecond shift times. Electronic systems. Cutting-edge electronic systems provide capabilities beyond conventional engine management and control systems. Multi-ECU systems coordinate multiple computers for engine management, transmission control, suspension control, and aerodynamic management. These require sophisticated communication protocols and integration expertise. Standalone engine management systems provide complete control over ignition, fuel, and boost systems. Professional ECUs, like Motec M1 series, offer 1,000 plus Hz processing speeds and unlimited tuning flexibility. These systems cost $5,000 to $20,000 and require expert calibration. Custom CAN bus networks allow communication between all vehicle systems. This enables features like coordinated launch control, traction management, and automated setup changes. Artificial intelligence integration uses machine learning to optimize vehicle setup based on track conditions, driving style, and performance data. These systems continuously improve performance through data analysis. Wireless data transmission systems provide real-time communication with pit crews, automated data logging, and remote vehicle monitoring. These systems use cellular, Wi-Fi, and dedicated radio frequencies. Advanced sensor integration includes tire pressure monitoring, suspension position sensors, aerodynamic load sensors, and driver biometric monitoring for comprehensive vehicle and driver analysis. Equipment integration. Professional safety equipment goes beyond basic roll cages to comprehensive protection systems designed for extreme racing applications. Automatic fire suppression systems detect and extinguish fires without driver intervention. These systems use heat sensors, flame detectors, and specialized suppressants to protect both vehicle and driver. Emergency extraction systems include breakaway panels, quick-release mechanisms, and emergency communication systems. These allow rapid driver extraction in emergency situations. Professional data recording systems capture video, audio, and telemetry data for accident analysis and performance optimization. These systems provide crucial information for safety improvements and setup optimization. Integrated communication systems provide pit-to-driver communication, emergency alerts, and coordination with race officials. These systems are essential for professional racing applications. These modifications represent the absolute pinnacle of automotive engineering, requiring professional expertise, specialized equipment, and significant investment. They transform vehicles into purpose-built machines that push the boundaries of what's possible, often making them unsuitable for street use while delivering ultimate performance capabilities. Each modification requires careful planning, professional installation, and ongoing maintenance by specialists with racing and engineering expertise. If you enjoyed this breakdown, subscribe for more. See you in the next video.